everybody. So today we're going to look a little bit about wind resource assessment. And just start out with a little bit about St. Francis University, in case you haven't heard of us. We're about 83 miles to the northeast of where we presently are. And the university was founded in 1847. It's one of the oldest Catholic universities in the country. It's a liberal arts focused education. There's undergraduate and graduate level programs. Some of the notable majors include petroleum, natural gas engineering, environmental engineering, environmental science, and computer science. Some of the alumni from the university include Charles M. Schwab, who is a steel magnate from the area, as well as Marie Stokes, NBA Hall of Fame.
So the Institute for Energy is a part of the university. We are a nonprofit organization, and we were founded in 2005, originally as the Renewable Energy Center. We focus on research and education, and we serve all counties in Pennsylvania. Our mission of the Institute is to promote research and to educate businesses, schools, policymakers, and communities in the development of cost-effective, environmentally sound energy solutions. We're currently funded through the Reinvestment Fund, but our previous funders include the USDA, Community Foundation for Alleghenies, and many more.
So we'll take a little overview look here of wind energy in Pennsylvania. Then we'll focus on how GIS can be used for successful turbine placement. We'll show you our interactive online wind explorer, which you can access through our website, and we'll get an example project. We'll look at some other factors used for turbine placement, look at a few resources, and then take your questions. So if we look back to the mid-1800s to the 1930s, windmills were actually a common part of the landscape of the United States, including here in Pennsylvania. They were used on farms and homes to pump water, and some even generated electricity. But as power lines extended to rural areas, their use declined. That is, until more recently.
So Pennsylvania has been harvesting wind energy for utility scale electricity production since 2000, so 14 years now. We have 24 commercial operating wind farms with around 1,300 megawatts of installed capacity. And according to a recent NREL assessment, we think that wind energy could provide up to 6.4% of our state's electricity needs. So today we're going to talk mostly about wind farm development, and that's where we use GIS the most. So what sort of spatial characteristics determine wind power feasibility in Pennsylvania? So the number one kind of no-brainer is wind resource. We have to pick a spot that has an available resource. So we use wind maps to do that, and we're going to talk more about those wind maps in a little bit. But after we've determined that there is a wind resource, we start looking at other features such as topography, terrain, and then we start to get into more nitty-gritty location and proximity of transmission access, environmentally protected areas, how close are we to those areas. Federal and state game lands play a big role in wind farm development, and then there's many other limiting factors that we're going to touch a little bit on later as well. So like I said, we use GIS to quantify the relationship between those spatial characteristics, and then we use them to more accurately and efficiently site a wind farm. So the number one thing we check, like I said, is there a resource? And we start by using wind maps. So there's a variety of companies all over this country and across the world that develop these wind maps. We use a company called AWS True Power. They're based out of Albany, New York. So they have collected data and have built these models based on actual weather data and topographical and surface roughness information to depict the average annual wind speed at a 200-meter resolution.
So we deal with a number of different clients, everyone from residential homeowners to farmers, small businesses, and developers. And each is looking at a different project size, anything from a small wind turbine at their home up to a full-scale wind farm. On the small scale, a typical turbine may be somewhere from 15 to 40 meters tall, and you're looking at a 4.5 meter per second wind speed to make a project feasible, about 10 mile per hour wind speed. scale that up to utility size, and we're looking at about a 60 to 120 meter tall tower. 100 meters quite common, and that's where the blades, the hub, the wind is going to interact with the turbine. And we're looking for probably at least a 7 meter per second wind speed for a commercial turbine to make feasible sense. So through the map that you saw on the couple slides back there, the blue colors from AWS, we took and made them kind of more accessible to the public, and kind of made the layers just a few colors here. So they're just a couple different classes. At a 30 meter hub height, starting at 4.5 meter per second, or about a 10 mile per hour wind speed. That's the tan areas you can see on the map here. And then the orange, and then there's a few blue spots on here. Those would be a better wind speed. But you can see that primarily there's a few areas in Pennsylvania where we would say that a turbine would be feasible. Up along the lakeshore of Erie, along the ridges of the Alleghenies in the southwest corner of the state, up towards the Poconos in the northeast, and a little bit down in the Lancaster, York area.
So the orange color represents what's known as a Class 2 wind speed, and the blue areas represent what's known as a Class 3 wind speed. So in order to have a feasible residential scale project, you want to see something in the orange area. And in order to have a feasible utility scale project, you want to see something with a blue shaded area.
And the tan area would be okay.
And a tan area would be considerable for a residential scale.
Given that there's not much resource there.
And so this map, like Michael said, is depicting those average annual wind speeds at 30 meters. So now we're going to look at 50 meters.
And you can see that the trend continues along the Lake of Erie's. They're probably some of the best resource. Constant theme of the higher elevations than elsewhere throughout the state. And then if we scale that up to 100 meters, this is where the utility scale is now developing. Before, say 10 years ago, 50 meters may have been okay, measuring wind speeds there. Now, a lot of the development has turned higher. And you can see that along the lakeshore of Erie there, very good, and along the ridges once again. If we were to plot where the current wind turbines have been placed, the wind farms, you'll see that it correlates very well with those blue areas where AWS expects the best wind speeds to be. We have county wind maps also available. These are all available on our website, free and accessible to the public. This is Washington County, and you can see the orange somewhat throughout the county, but there's not really any blue. If we were to look to, say, Somerset County, that's got some of the best resource in the state. There are 8 commercial wind farms operating currently, and there's definitely potential for future development. At our campus, back at St. Francis, we've got a 120-foot tall wind turbine, small wind turbine. It was installed in 2009. It's a 2.5 kilowatt machine. And when they were debating where to place it, it's the area down in the center here, the square right down here. And they were originally going to place it, though, potentially up here on this hill. There's a soccer field here, though, and I'm not exactly sure what exactly they were going to do, but they were concerned that students may run into it. So they decided to place it down further below that. The problem with that is it was a decrease of 26 feet. And you can kind of see here from the picture that variation in elevation. Here's the completed project, and one of the neat things just before we move on is you can see the commercial utility scale wind turbines off in the distance. And so this was an example project just so people could come and see it, and it's neat that you can see both scales there and we can compare for educational purposes. So we have this program available on our website, and we'll take a look here of that project. You can create a free account and get access to 30 meter data, and then there's also, you can get a subscription for more advanced data up to 100 meters. It's a very simple interface. Anywhere in Pennsylvania you can click, and if you click, it'll give you wind speed, a wind row showing what direction the wind is coming from, a monthly speed distribution chart, and a bunch of useful information if you were siting a turbine. If we were to zoom in closer to the campus here at St. Francis, and once again, you can see here we're back to that same location. I've placed the the pin on there, and we've got a wind speed of about 4.6 meters per second. So it's slightly over our 4.5, potentially a feasible site. However, had we gone with that first site, the soccer field, we would have increased to a 4.81 meter per second. It's only like, what, 25 feet difference or so? But you can see just how small differences can make a big difference in terms of the resource you're getting. And then we can also, this is an example of a report you can get.
All right, so Michael just talked a little bit about residential scale development, and I'm going to talk a little bit more now about utility scale development in Pennsylvania. So our center owns these two pieces of equipment. You probably may or may not recognize them. One of them is a Met Tower. It's a 60-meter NRG meteorological tower. And we also own a Triton SODAR. We heard a little bit about LIDAR earlier. SODAR is very similar to LIDAR, instead it uses sound instead of light. So we use this SODAR to collect data to verify the wind maps. So we start with the wind maps in development, and then from there the bank requires us to show them, yes, that those maps are indeed correct. So we are hired by either a developer or an interested landowner, and we'll set up these pieces of equipment and take data. We have been very successful with this. We have had 4 of our Met Towers that we've erected turn into utility scale projects in Pennsylvania, so we're really proud of our track record. So our most recent project was in Patton, Pennsylvania, which is in Cambria County. We were approached by this landowner who thought that they had perfect land to develop a project and were interested in putting turbines up. So we did an initial site assessment like we talked about. We looked at these wind maps, and as you can see, we're in the blue and orange areas. So yes, this project from an initial standpoint looks great. So we went ahead and we put up one of our Met Towers there, and that's depicted by the red dot. And we collected data for 2 years. And our data showed that yes, the wind map data was correct, and actually I think it showed that we had a better resource than we had even that the maps had shown. So this project was purchased by a developer and went into construction in 2012 and commissioned at the end of 2012 and production in 2013. So along with our initial wind resource assessment, we have other assessments to do. Most notably our environmental impact statements. I'm sure if you're in the energy industry in Pennsylvania, you're very aware of environmental impact statements. And our biggest issue with wind energy development in Pennsylvania right now is the Indiana bat and the soon northern long-eared bat. So we work with developers in developing habitat conservation plans and incidental take permits for these species. So other issues in site assessment include transmission interconnection. So we can use GIS to map what kind of transmission opportunities we have for a site, as well as what are our electricity prices in that area, what kind of locational marginal pricing are we looking at, and we can culminate all this data to really understand it better when we're doing our initial site assessment. Another thing, road access. Nobody wants to spend billions of dollars in building small roads to access these turbines, so that becomes another mapping technique we could use. Airports and radar. So wind turbines cannot be within a 3-mile radius of airports, and they greatly affect radar, which Michael's going to talk a little bit about.
And so I find this really interesting because back where we're from there, this is Cambria and Blair County, you'll see that there's a rainstorm up to the north on the radar, but some of these areas, the circle, that I've outlined, there's a circle.
Sorry.
There. Some of these areas are staying stationary, and this is actually the radar picking up the wind turbine spinning. I can't differentiate between the precipitation coming down and the moving blades because it's just picking it up as movement and it's showing up on the screen. So this could potentially become a hazard in an area, say, where there's a high likelihood of tornado. So you have to position them or know that they're there in order to for safety.
Other issues are ordinances, setbacks, and like Michael said about Erie, community opposition. So if we can get all of this data into one data set and be able to look at Pennsylvania as a whole and know that there are some areas that are just not developable because of these reasons, we've saved ourselves a lot of time and money. So, in summary, GIS analysis and wind energy reduces the risk of choosing a poor site. In the last few years, the developers that we work with do not function without their GIS software and data inputs, because years before, we would put Met towers up and start a whole site development process and be unsuccessful with it, because once we saw, yes, there's a great resource, but then we didn't have the other data that showed the ordinances and the issues with community opposition, and we didn't have transmission all in one place to be able to do a seamless site evaluation. So it helps identify potential problems early and helps to predict the total wind farm energy output, which equates to profitability. Other great resource to check out would be this AWS True Power Open Wind. They have many different layers that you can work with to site a whole wind farm or site turbines in a specific wind farm, as well as the USGS wind farm website that shows the different wind farms throughout the US. So that concludes our presentation, and we'd love to take any questions or comments.